Hello friends, welcome back to my channel. Today we are going to see the art of curved arrow drawing in organic chemistry. Curved arrow are used to show the electron movement, reaction mechanism, resonance structure, and they are also used to understand the reaction intermediate and clarify the reaction condition. So let us see the art of drawing curved arrow in organic chemistry in detail. Today's content will be on the three main points. The first will be the rules for the arrow drawing. The second will be the tips for arrow drawing. And in the last, I will show the common mistakes done by a student while drawing the reaction mechanism with the help of curved arrow. So let us start with the first rule. The first rule is the arrow indicate the movement of electron in reaction. To show the arrow in organic chemistry, two types of arrow are used. The first one is the double-sided arrow and the second one is the single-sided arrow. When there is a movement of two electron pairs in a reaction, it is denoted by the two-sided arrow. And when there is a movement of one electron in a reaction, it is denoted by the single-sided arrowhead. These two types of a arrowhead are used for a specific type of a bond cleavage in organic chemistry. So there are two types of a bond cleavage. The first one is the heterolysis and second one is the homolysis bond cleavage in organic chemistry. In heterolysis, there is an unsymmetrical breaking of a bond between A and B which generate the cation and anion. Anion possesses an electron pair, so it is denoted by negative charge. In homolysis, there is a symmetrical cleavage of a bond generating the two radical. This is the example of heterolysis and homolysis. The first one is the example of bond breaking between the chloride and the tertiary butyl group, which generated the tertiary butyl cation and chloride ion. And second one is the homolysis or single electron bond cleavage between the chlorine, generating the chlorine radical. So when there is an heterolysis bond cleavage, we generally use the double-sided arrow. And when there is an homolytic bond cleavage, we use the single-sided arrow. The second rule is we should not use an arrow to indicate the movement of atom directly. So arrow are generally used to indicate the movement of an electron during the bond breaking and bond making in an organic chemistry. This is one of the classical examples. So this is a correct use where we denoted that the anion abstract and proton water is generated and the acetate ion is generated. So common mistake is that, or commonly we are considering the proton is attacking on the hydroxide ion to generate water molecule and we get the acetate ion. So in the incorrect scenario, we have shown the migration of an proton on the alkoxy or what you call as hydroxyanion. So the correct use is that the lone pair of an oxygen or negative charge abstract the proton without any electron generating the acetate ion and water molecule. The third rule is arrow always start at an electron source and ends at an electron sink. So it is clearly indicating that the movement of an arrow is from the negative charge to the positive charge. This is one of the example where Grignard reagent is attacking on the carbonyl bond. So generally, it we get the Grignard salt, and the in the last step there is hydrolysis of Grignard salt generating the alcohol. Let us consider this Grignard salt in little bit detail. So this magnesium is positively charged, generating the delta negative charge on the carbon. So it can be clearly understood that there is a negative charge on the aryl ring and the magnesium bromide possesses a positive charge. So during the course of a reaction, we have to show the arrow from electron source to electron sink. So this carbon is an electron source bearing a negative charge will attack on the electron sink. This carbon is highly positive positively charged due to presence of the oxygen atom. So the arrow is shown from the electric source to electron sink. Fourth rule is that we have to avoid the overfilling of an atom. So this is the example where the hydroxyanion is attacking on the carbon, even attacking on the proton, generating a bond between hydrogen and hydrogen and oxygen of this carbon. So this proton now has two two bond between the two oxygen atom. So there is an overfilling of this valency of this proton. So one of the bond has to be broken. It can break the carbonyl oxygen bond or alkoxy or hydroxy oxygen bond between the proton. So when this bond is broken, we will get the starting material back. Now consider the bond breaking of this oxygen of this carbonyl. So the bond between the oxygen and hydrogen is broken, generating the stable acetate ion. So we, by generating the stable acetate ion and water molecule, we have avoided the overfilling of this hydrogen atom. So this has to be remembered. Now let us see some tips for the drawing arrow in organic chemistry. The first tip is that make a bond between the nucleophile and the electrophile. So as this is the rule, we have stated that the arrows start from an electron source to electron sink. So in this case, the nucleophile is the electron source and electrophile is the electron sink. This is the example where this water molecule is used as the nucleophile on the isopropyl cation intermediate, which has a positively charged. So it is an electrophile. There is a attack of a lone pair of oxygen on this positively charged carbocation, generating the oxonium intermediate. So the correct use of arrow is from the nucleophile to the electrophile. The second tip is the break a bond so that relatively stable molecular anion are created. So in this example, this is an ethyl acetate. In ethyl acetate, the carbonyl, one of the lone pair of an oxygen on the carbonyl group attack on the hydroxyl anion. So when this attack takes place, the bond between the hydrogen and oxygen cleave, generating the stable water molecule. Whereas we get the protonated intermediate, which is stable in the acidic medium. So this can be from these tips, it can be clearly understood that the bond breaking is done to generate the stable molecule. The third tip is the add a proton. So use this element when there is no suitable electrophile or nucleophilic reaction, but the molecule has strongly basic functional group, and when there is an acid present in the reaction. So in this case, we have to add the proton. So proton is added on the carbonyl oxygen. Why it is added on this carbonyl oxygen? So when there is a generation of this protonated intermediate, the bond between carbonyl can be easily cleaved. So we have added the proton on the oxygen, generating the stable protonated intermediate. So when there and in this tips works only in the acidic medium. So in acidic medium there is excess of positively proton present in the medium. So these protons add up in the reactant, generating the protonated intermediate. Similar case can be used when there is a presence of nitrogen in the starting material. So the fourth tip is take a proton away. So in acidic medium we have to add the proton, and when there is an basic medium we have to remove the proton. So in this case the oxonium intermediate form is highly possess an extra proton. So there is an overfilling of this oxygen atom, generating the positive charge and oxygen. So we can take this proton by using the water molecule. So water is the act as a base and the acidic proton can be removed with the help of water, generating the protonated water intermediate. So in this case, proton is abstracted, generating the 2-propanol. So when there is an presence of an overfilling, or when there is a positive charge intermediate present in the reaction, it can be removed with the help of base or the water, generating the stable molecule. Now let us see the common mistake done while doing the arrow drawing. The first mistake is the backward arrow. So in this case, there is a attack of an proton on the double bond. So this will never happen. So the correct way of the representation is that the double bond possesses an high electron density due to the presence of pi bond. So this pi bond attack on the proton, generating the bromine anion and the protonated intermediate. Second mistake is not enough arrow drawing. So generally it is done when we miss to write some of the arrow for showing the reaction mechanism. This is one of the example. In this case, this anion is abstracting the proton and bromine is liberated. We are getting the alcohol and the double bond species and the bromine anion. So this is incorrect way. The correct way is the attack of the oxonium anion on the proton. This bond is getting backward, converting to double bond, and that case the bromine is also liberated. So this is the correct way of showing the arrow. The third one is the hypervalency. We have already shown that we should never show the hypervalency. So this is the incorrect way, where this the one of the oxygen of nitro group is going back to generating the double bond between the nitrogen and oxygen. So in this case, the nitrogen has an 5 valency. This is the incorrect way. The correct way is when there is a uh, push of this electron on the nitrogen. At the same time, the another bond between the nitrogen and oxygen is opening, generating the anion. In this case, we get the 4 valency on the nitrogen and stable compound. Second example is the attack of a nitrile on this uh, hypervalent oxygen atom. So in this case, we are overfilling the oxygen atom. Fourth point is the common mistake done, that is failing to convert charge. So in this case, there is an attack of an hydroxide and on the methyl acetate, generating the one of the product according to this reaction. So this is never going to happen. In this case, the carbon has the 1, 2, 3, 4, and 5 bonds. So carbon should be 4 bond. So the correct way is this hydroxide and attack on the carbon, pushing back one of the double bond on this oxygen, generating the anion. In this case, we get the oxygen negative charge on the oxygen, and the carbon is in this carbon has 4 valency. So we should in this case we should have a negative charge on the oxygen atom. So this is the correct way, and we have conserved the charge and the valency of an reactant. Let us apply one of the tips, the rules in the example. So in this case, I have chosen the benzoin condensation. So this is the correct mechanism shown in the for the benzoin condensation. In the first step, there is an attack of an nitrile ion on the carbonyl bond, generating the generally the negatively charged intermediate. In the second step, there is an abstraction of this acidic proton by the base, conjugate base of this water, generating the cyanohydrin intermediate. In this case, this negatively charged species attack on the positively carbon of an benzaldehyde, generating the benzoin intermediate. In the last step, there is a uh, pushback of the negative charge of an oxygen atom, generating the double bond between the oxygen and carbon, and displacing the nitride to get the benzoin. So in this case, I have shown the correct use of an arrow for a given reaction and its mechanism. Thank you guys. Hope you liked my video. Please share and subscribe.